we're going to look at a different way to solve these problems using a system called conversion factors or factor label. So the big idea with this is you can take and make an equal statement. So I'm going to look, it says, given the previous equation, write a conversion factor for the relationship between aluminum and zinc. So if I look at aluminum up here, I see that there is 2 moles of aluminum. So I'm going to write 2 moles of aluminum, okay, equals how much zinc? I'm going to look up here at the balanced equation, that coefficient, that big number in the front, 3 moles of zinc. So that is my equal sign. This is my conversion factor. Here's the cool thing. I can take and divide both sides here by 3 moles of zinc. Okay. And notice, on this side, 3 cancels with 3, mole cancels with mole, zinc cancels with zinc. So all of this stuff cancels out. The miracle of math, it's not a miracle, but it's exciting, is that equals 1. So all I'm really doing is taking and multiplying by 1 when I multiply and use this conversion factor. So let's go ahead and do the next problem here. It says use your conversion factor to predict how much aluminum will be formed when 9 moles of zinc react. So I'm going to start with 9 moles of zinc. Okay, 9 moles of zinc. I could do it, I often like to do what I call the train track method, which is like this. I'll show you a different way on the next one, but your choice on how you want to do it. 9 moles of zinc, and I just kind of put a 1 there as like a placeholder. Then I'm going to use my conversion factor, 2 moles of aluminum on top and 3 moles of zinc on the bottom. Notice a couple things. Notice that zinc is up, that moles of zinc is here and moles of zinc is down here. This is different than when I use the ratios because I am multiplying. It is not an equal sign. So this right here, this train track, it's a multiplication. So it's this times this. Since I'm multiplying, when I multiply and divide by something, they cancel out. So that's why I'm doing it this way, and I figure out what cancels out based on what's on the top here. So moles of zinc cancels with moles of zinc. So I'm going to end up with the answer is going to be moles of aluminum. It's going to be moles of aluminum, which is what it's asking me for. 9 times 2 is 18, divided by 3 is 6. So my answer would be 6 moles of aluminum. So for the next one, it says, write the conversion factor for the relationship between ZnO and aluminum. So ZnO, if I look at that coefficient in the front, it's 3 moles of ZnO. And aluminum, it's 2 moles of aluminum. And I'm just going to leave my conversion factor like that. So now it says how much aluminum will be formed when 1.58 moles of ZnO are formed. So I'm going to do this one just with like a parentheses and put the number 1 below just to show that the ZnO is on the top. I'm going to do my parentheses here. So again, this is exactly the same as doing like the train tracks. If I put this information here and then I wrote this information here, okay? So it's just another way to look at it. Since I'm multiplying, big, huge idea, moles, what's ever up here has to go down here. So I have to put moles of ZnO down here. Moles of ZnO, so I know the number, as I look up here, the number is 3 that goes with it. So 3 moles of ZnO. And then on the opposite side here, so if this is what goes on the bottom, 3 moles of ZnO. So if I divide this, 3 moles of ZnO, 2 moles of aluminum is what goes on top. 2 moles of aluminum goes on top. Moles of so now I'm going to have my fun canceling things out. Moles of ZnO cancels with moles of ZnO. And I'm going to get moles of aluminum left for my answer. Moles of aluminum, so I'm going to have 1.58 times 2 divided by 3, and I get 1.05. Oops, 1.05 moles. Okay, I'll just do it down here. 1.05 moles of aluminum, and that will be my answer there. So there we go. And so that is how I'm going to solve these problems. So let's do another one. Next one here says, write the conversion factor between aluminum. So there's 2 moles of aluminum equals 1 mole of Al2O3. So how much of Al2O3 will be formed when 0.7 moles of aluminum is formed? So I start here at 0.7 moles of aluminum. I do my train tracks here. What has to go on the bottom to cancel with moles of aluminum here? Moles of aluminum. What number goes with moles of aluminum? That 2. This 2 right here goes down here. So that 2 is going to go right down there. Then the top here is over here. 1 mole. Because again, remember, I just am multiplying by like 3. I'm sorry, I'm multiplying by 1. Excuse me. And so I'm not changing the value at all. I'm changing the unit. So moles of aluminum cancels with moles of aluminum. And I get 0.35 moles Al2O3. And that is my answer. So that's how you do that with conversion factors or factor label method.